Section 3.1 is on page 150, talks about coordinates and graphs. We talk about two main things. To start with, the distance formula and the midpoint. Given 2 points, x1, y1, and point 2, x2, y2. The distance formula, the distance between those is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And the midpoint between those, or if I want to find the midpoint, I average the x's, so you add the x's divided by 2, and I average the y's, add the y's, and divide it by 2. So on the following problems, I'd like to find the midpoint and the distance. And let's see how this works. If I want to find the distance, that's the square root of, this is 0.1, this is 0.2, x2 minus x1, y2 minus y1, minus a negative 4 is a plus 4, plus x2, which is 5, minus x1, which is 11 squared. The distance would be the square root of, this is 16 squared, plus a negative 6 squared, and the distance would be the square root of 16 times 16, 36, a 9, a 6, and a 1, 256, plus 36. The distance would be the square root of a 12, 9, and a 2, 292. That is a fine answer. The book wants us to use a calculator. We're not going to use a calculator on this. To round. Now, 292, if I break that up, that's 2 times 100. 2 divides 9 4 times. There's 1 left over, 46. 2 and 73. So I could take a 2 out of that, because that's 2 times 2. That will be 4, the square root of 73. That's as simplified as we can go. So this would be the final answer. Now, if you want to find the midpoint is a bit easier. Take the x's, which is 11 plus 5, average those. And take the y's, negative 4 plus 12, and divide that by 2. The midpoint would be 11 plus 5, that's 16, divided by 2 is 8. Negative 4 plus 12 is an 8, divided by 2 is a 4. There it is. Fairly simple. Another example, if I want to find the distance between those, that's the square root of x2, y2 minus y1, so that's 4, minus a negative 3 is plus 3, plus x2 minus a negative 2 is a plus 2. I should put the radical after. And distance would be the square root of 7 squared, that's 49. 5 squared is 25. The distance would be the square root of 74, if I'm not mistaken. 74. And I could take 74 and break that up. 74 is 2. 2 divides 7 3 times. You have 1 left over. 37, so it doesn't reduce. That would be it. The midpoint for this problem would be, take the x's, negative 2 plus 5 plus 3 divided by 2, and negative 3 plus 4 divided by 2. That would be negative 2 plus 3 is 1, so that's 1 over 2. Negative 3 plus 1 is 1, and that's a 1 over 2. So, midpoint and distance. Let's do 2 more, just to make sure we're getting this. If I want to find the distance between those, the distance is the square root of y2, which is negative 7.2, minus y1, which is 3.8 squared, I did the same mistake, plus y2, which is negative 1.2, minus a negative is plus 2.5 squared under a radical. The distance would be the square root of, this would be a negative 10, 11 squared, plus, and if you subtract those, that will be a 3, 1.3 squared, and that would be a square root of 121, and 1.3 times 1.3 is 1.69. And the distance would simply be the square root of 122.69, and that's a good enough answer. If it's decimal, you don't have to worry about it. Under a radical, basically you have to use a calculator, and we're not going to use a calculator, not yet. And if I look for the midpoint, again, that's always simpler. That is, take the x's and average them. Negative 2.5 minus or plus a negative, that's still a negative, over 2. And if you take 3.8 plus a negative 7.2 divided by 2, midpoint would be, this would be a negative 3.7 divided by 2. 2 divides 3 one time, and 2 divides 17, let me see, 2 divides 17, 8, 5. And here, if I subtract those, if I take 7.2 minus 3.8, 8 out of 12 is a 4, 3 out of 3, that's 3, positive. And if I take 2 divides 3 one time, you have 14 left, 1.7. And on the last problem, if I want to find the distance, that's also the square root of 8 minus 3 plus 7 minus a negative 11 plus 1 squared. Distance would be the square root of 5 squared, which is 25, plus 8 squared, which is 64. Distance would be the square root of 989. There you go. And the midpoint would simply be the first x plus the 7x divided by 2, the first y plus the second y divided by 2. Midpoint would be, that's a 6 over 2, 3, and that's 11 over 2. You could leave that as a fraction, or you could write 5.5, makes no difference. Now, an equation of a circle. When you look at a circle, you're going to see two squares equaling a number. The center of the circle is always the opposite of what you have there and the opposite what you have there. And the radius, of course, is that number. If you center it at 0, if you have x squared plus y squared, then the center, it's like you're not subtracting anything, you're really subtracting a 0 from there and a 0 from there, and the radius is r. So we have one example on this, and the rest we have to really work at it to get it to match that. And here they say, graph the circle. Graphing a circle is fairly simple if you have it in standard position. All what you need is figure out what the center is, and remember the opposite of that and the opposite of that. And the radius, you're asking yourself, what do you square to get 144? 12. So if I move negative 1, negative 2, negative 3, 1, 2, 3, there's the center. You move 12 units in all directions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. I should have rescaled this. Yeah, it's not going to fit. this is how I'm going to do this. I'm going to do that a bit different. I'm going to say this is a 3, a 6, a 9, a 12. So each of those units is 3. So if I go 3, negative 3, 3, I'm right there. 3, 6, 9, 12. 3, 6, 9, 12. 3, 6, 9, 12. And 3, 6, 9, and 12. Connect that with one of those magic lines. If you could get it to match, there's the circle. So once I know the center and the radius, I'm in good shape. Now, if I take the following, the catch is to get them in standard form, and that takes a bit of work, not a whole bunch. Here, it says, write each equation in standard form, then identify the center and the radius. Here, I'm going to get the x's by close to each other, and I'm going to add a number to the x's. I'm going to get the y's together, and I'm going to add a number. I'm going to move the 205 to the right. Whatever number I add to the x's, I have to add on the other side. Whatever number I add to the y's, I have to add on the other side. So I'm going to take, if you remember completing the square, take half of the middle number. Half of 8 is 4, and square it. And this becomes x, always that sign, the number before you squared it squared. Plus, take half of the middle number, which is a 2, and square it, you get a 4. And this is going to become a perfect squared y with that sign, the number before you squared it squared. And here, this is 20, this is 225. Now that I have it in standard form, the center would be the opposite of that, which is a 4, the opposite of that, which is a negative 2, and the radius would be, what do you square to get 225? 15. That would be the answer. So a bit of work, not that hard, just completing the square twice. Okay, doesn't seem I'm going to be able to fit all of those. That's okay. Let's do that one. We need to squish things together. So here, the same deal. I would take the x's and put those together, x squared minus 6x, and I'm going to add a number. Plus, I'm going to get the y's together, y squared minus 2y, and I'm going to add a number. I would move the 26 to the other side. Whatever number I add to the x's, I must add on the other side. Whatever number I add to the y's, I must add on the other side. Take half of 6, which is 3, and square it, that becomes a 9. That's a perfect squared. X, always with that sign, the number before you squared it. Take half of 2, which is 1, and square it, you get a 1. And this would be a perfect squared as well. Y, always with that sign, the number before I squared it. The right side, this is a 10, plus 26 is 36. The center would be a 3, the opposite of that, and the opposite of that. And the radius would be, what do you square to get 36? A 6. Now, we get to this part. Write the equation of each circle where the given coordinates are the endpoints. Again, it seems I'm not going to be able to fit 3, we could fit 2, that's alright. So, they're not asking for a graph, but I just want to show you kind of what's going on. If I take 1, negative 4, 1, negative 1, negative 2, negative 3, negative 4, and negative 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. So if you could imagine a circle, again, the graph is not part of the problem, and the circle is passing through the write an equation of a circle where the coordinates are the endpoints of the diameter. The special property of a diameter is that it passes through the center of the circle. The goal is to find what that center is, and that center is the midpoint. So the center is really the midpoint of the endpoints of the diameter. If I take 1 minus 7 divided by 2, negative 2 plus negative 4 plus 8 divided by 2, the center, which is the midpoint, would be a negative 6 divided by 2 is a negative 3, and 4 divided by 2 is a 2. I just got the center. So up till now, I know that the equation is x plus 3 squared plus y minus 2 squared equals r squared. All what I have to do is figure out what r is, and now again this graph is not part of it. I'm going to shrink that and push it to the side. The book uses the distance. We have a quicker way. We need to know that any point on the circle, any of these points satisfy this equal. If I pick one of these points, either I pick negative 7, 8, or I pick 1, negative 4. If I substitute one of those points for x and y, I will get what r is. That's a lot more efficient than the book's method. If I take, for example, 1, 4, x and y, I would say 1 plus 3 squared plus negative 4 minus 2 squared. That equals r squared. Let me shift that down just a bit. So this is 4 squared, that's 16. This is negative 6 squared, that's 36, equal r squared. And if I add those, 12, 3, 4, 52. So I would write x plus 3 squared plus y minus 2 squared equals r squared, which is 52, and that would be the standard equation for the circle. And if I do the same on the next problem, again, the graph is not part of this. I'm just doing this graph for reference, nothing more. I will shrink that after I'm done with it. So if I look at the endpoints being 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, and negative 4, 8, 1, 2, 3, 4, 5, 6, 7, 8. And if I fit a circle through that, that should be the diameter. There it is. If I put a line now connecting those 2 points, and those are on the actual circle, I'll know that somewhere halfway is the center. So the center is really the midpoint, which is 6 minus 4 divided by 2, and 4 plus 8 divided by 2. The center would be 2 divided by 2 is a 1, 12 divided by 2 is a 6. So now I know it's x minus 1 squared plus y minus 6 squared equals r squared. And I'll use the same trick. I pick one of those, whichever point you want. I'm going to pick 6, 4. And remember, that's x, that's y. If I substitute 6 for x, 4 for y, that equal should hold because this point is on the circle. 6 minus 1 squared plus 4 minus 2 squared equal r squared. This is 5 squared, 25. 2 squared is 4. So I'm getting the radius to be 29. And now my equation becomes x minus 1 squared plus y minus 6 squared equals 29. And there it is. The radius is the square root of 29 here. The radius is the square root of 52. But they just want to write the equation. And the last aspect of this section is symmetry. And let me elaborate on that a lot. We're not spending a lot of time on this symmetry because it's going to come up in sections in the rest of chapter 3. So if f of negative x equals f of x, then f is an even function. If f of negative x is negative f of x, then f is an odd function. And even functions is symmetric with respect to the y-axis. And an odd function is symmetric with respect to the origin. What this means one more time, I need a new stylus, I guess. This means if you replace odd function, if you replace y by a negative, the point stays on the graph. And here, if you replace x by a negative and y by a negative, the point stays on the graph. Again, we're going to elaborate on that once we get to 3.6, 3.4, and 3.5. So what I do, I say, well, this is f of x. Replace x by a negative. The good news, you do the same thing for both of those. You replace x by a negative. In both cases, you're trying to see if the negative disappears. F of negative x equals negative 2x cubed. So you check, is this what you started with? If not, that didn't happen. The negative didn't disappear. This is not an even function. I'll just say not even. And one step further and you're done. Factor a minus out of this. And you check, is this what you started with? Since it is, it's that case. This is an odd function. So this graph is symmetric with respect to the origin. And on number 70, the same deal. We say f of x equal 2x to the 4th plus 3x. Replace x by a negative. It's two-step process. Clean that up. And is this identical to that? If that's not the case, this is not an even function. Factor a minus out of it. That's negative 2x to the 4th plus 3x. And you check, is this what you started with? It's not, so you say this is neither. And the homework is listed